Welcome again folks and glad to have you back. In this lecture I will help you develop understanding on Java annotations in case you don't have that already as part of your Java programming journey because I will be using annotations to develop web services. In case you already have that understanding, you may safely skip this lesson. So what really are annotations in Java? Annotations represent metadata. That is, they are used to add metadata to Java elements like class, method, field, and others. And why do we need annotations? The idea is to provide metadata to elements exactly where it is required rather than putting in an external XML file. Now let me introduce here the syntax to annotate different elements in our Java classes. Annotations are differentiated from other elements like a class or an interface by preceding or by prefixing an character before it. An annotation definition looks like the example here on the right. I am defining a test annotation by using interface before it. In Java, we can even annotate an annotation, that is, add metadata for an annotation itself. This is referred to as annotating an annotation itself. That is, metadata for an annotation. I will share here a couple of most commonly used examples on this. Target annotation or @target with T caps tells for which element type this annotation is applicable. For example, @test annotation in the example here on the right can be applied only to the methods and not to any other element type because annotation is using element type dot method. There are quite a few target types that gets applied at pretty much every element level of a Java class or an interface. As you see here on the slide, the possible values for target types are type, and type target is applied only to type, and a type can be a Java class or an interface or even an enum or even an annotation itself. And field target is applied only to Java fields and even applies to enum constants. Then the method target is applied only to methods. Parameter target is applied only to method parameters in a method definition. And constructor target can be applicable only to a constructor of a class. We also have local variable target, which can be applied only to local variables, that is, variables that are declared within a method or a block of code. So we see here that there is field target and local variable target. So field target does not apply to a method variable, and local variable target is not applied to a instance variable or a static variable. And then we have annotation type target, which is applied only to annotation types. And finally we have the package target that gets applied to a package. So these were the values that we can associate with a target annotation type, and most of these values, they were pretty intuitive. As you can we can guess from their name itself where they are applicable. Another commonly used metadata for an annotation is the retention policy and used as @retention. @retention is a mechanism through which we can say that to what extent the annotations should be retained. For example, whether it needs to be retained on the source code only or retained in the class file also, or it is to be retained during the runtime also so that JVM can make use of it. @retention takes possible values of source, class and runtime for each of the above cases. So if the value is source, the annotation will be retained only within the source file. If it is a class, then it will be retained only till the stage of its compilation into a class file. And if it is runtime, then the retention will be retained all along the runtime as well. In the example on the right, if we want to retain the test annotation information till the class file, I use retention policy.class. So this is the way we can set the retention policy for an annotation. Java provides a number of predefined annotations. And in this slide, I am going to share with you three of those predefined annotations which are override, deprecated and suppress warnings. @override annotation. It tells the compiler that whenever this annotation is tagged in a method of some class, then that method must be overridden by the developer. If not, then the compilers can report them as errors. We use override annotation to take advantage of the compiler checking to make sure we are actually overriding a method when we think we are. This way, if we make a common mistake of misspelling a method name or not correctly matching the parameters, we will be warned that our method does not actually override as we think it does. Although when we are using Eclipse and we are using the Eclipse feature to give us definition of the methods that we are overriding, then this situation is not going to occur. So, but there is another advantage of override annotation. It makes our code easier to understand because it is more obvious when methods are overridden. This is a much more significant advantage for me. So when I am writing my code with an @override annotation, and if you read my code, you can immediately understand that so this method was being originally provided by the parent interface or a class, and I'm overriding it here. The other inbuilt Java annotation is @suppress warnings. With the concept of generics starting from Java 5, references to any of the collection types can be parameterized, as the compiler will issue a warning message. For getting rid of this warning message in our code, we can define the return type like list of an object, thereby making the compiler happy. But if we are using a third-party jar or library, Java library, and it is using a generics code in the collections, right? And now if we start getting warnings by the compiler when we are adding values to that collection in our code, so we cannot go back to the third party library code and make changes to return as a list of objects. So we have no control over that code. The solution for this problem is to make use of @suppress warnings annotation. In the example here you see how it is used, and in this case compiler warnings of type unchecked will get muted. Let us look at one more predefined Java annotation, which is @deprecated. Imagine the case where a method defined in a class or an interface has now become obsolete, and we should warn the client applications not to make use of them. One bad idea would be to remove the method itself from the interface, but this solution has a huge impact on existing applications that are dependent on this interface. The more elegant way is to mark the old method as deprecated, which informs the client not to use this method anymore, because in the future versions this old method may not be supported, and at the same time this method does not impact existing applications because the method is still there but marked or tagged as deprecated. So folks, this should have helped you build some fair understanding on Java annotations. The reason why I have added this topic as part of this course is because I will be using annotations in developing web services using Apache CXF framework. So folks, bye for now and look forward to see you in the next lesson. Stay tuned.